Welcome to the topic coroutines. Before going into the coroutine, let's see the difference between a threads and coroutines. So threads are primitive. So primitive in the sense the thread pool executor suspend the low priority thread to get hold of the resources by high priority thread. So that's why the threads are primitive. But whereas a coroutine and coroutine dispatcher once confined a thread to the coroutine, it will never suspend a coroutine. So it is up to the coroutine to release that thread to the thread pool, and coroutine dispatcher is confined to another coroutine when it is available in thread pool. So coroutine dispatcher never force a coroutine to suspend forcibly, but whereas the threads or thread pool executor force to be in a thread to be in a suspend status. So that's why threads are primitive, but whereas coroutines are cooperative. Let's see how to define a coroutine. So let's see coroutines. So how to define a coroutine? We define a coroutine by calling a coroutine builder on coroutine contest. So available coroutine builders are launch and async. So coroutine contest is available scopes are global scope and coroutine scope. So global scope when you define a coroutine, when you launch the coroutine builder on the global scope, and that global scope means that the lifetime of thread is the lifetime of application. So what is the coroutine scope? So we can launch a coroutine on a coroutine scope, and this coroutine scope can be defined as a children of that parent scope, and so the lifetime of that coroutine is that parent scope. Let's see how to define a coroutine. So we define a coroutine on the scope, that is global scope, and builder, launch or async, and we give the statements to be executed on the coroutine. So here that it launched the thread on the global scope, and lifetime of this thread coroutine is lifetime of application, and so its delay function is a suspend function. So it delays for 1 millisecond, and when it calls the suspend function, its coroutine release the thread and returns to the thread pool, so that coroutine dispatcher confine that thread to another coroutine. So main thread to be wait till that coroutine finished, and we can delay like this, and but this is suspend function, we can't call a suspend function from the main thread. The suspend functions can only call from another coroutine. If we want suspend function to be called on main thread, to block the main thread till that suspend function finished, and we call that suspend function on run blocking. So it blocks the main thread till that delay function completed. So we can keep this entire thing in a run blocking. so that main thread will be blocked till that all coroutines completed in that block. But it is that the coroutine launched on the global scope, and so in that it doesn't block this main thread till that coroutine completed. So for that, what we need to do, that we define a coroutine child coroutine scope, and we call that builder on that child coroutine scope. And so main thread blocks till that all children coroutine scopes, the coroutines in the all children coroutine scopes is completed, and the parent scope will wait for to complete all children. So this called only after that coroutine is completed. And next, this see here that child coroutine is completed, and first is started and finished, and then only it's called the print ln statements. That means that is that it waits till that all children coroutines in the children coroutine scope is finished. So that is that you define a coroutine with the launch or async and the suspend function, and can only be called on in a coroutine. But if you want to be called the suspend function in main thread, and that has to be in run blocking. So we can define a coroutine scope as a children coroutine scope, and we can define the coroutines in that scope. So once all coroutines in the children's scopes completed, and that run blocking, and will block the main thread till that all coroutines in all children's scope is completed. So coroutine builder return a job instance, and whether it is a builder is async or launch, and it returns a job instance, we can call a cancel method on that, or join method on that instance. When it is cancelled, that coroutine will be cancelled when we join method call, and that thread waits for. The join method is a suspend function that has to be called on run block, and main thread will blocks till that join method complete, that is the coroutine is finished. So coroutine has to cooperate to be cancelled. So when we call a cancel on that instance, so coroutines cannot be cancelled if coroutine is working in a computation. If you want, it throws the exception, and if you want that coroutine to be cancelable even when doing the computation, and that we need to check for in that computation logic, we need to check for active status of that coroutine. As long as status is active, we do the computation. When we call the cancel, that active status will become false, and we need to stop that computation. In this way, we can make that coroutine cancelable. And so coroutine can keep in a try finally block. When coroutine executes or coroutine ended with exception, the final block will execute. So final block can have a suspend function, but it cannot be without cancelable. So mostly coroutine cancelled. So that is usually we cancel the coroutine on timeout exception. So instead of So keeping that coroutine in a final try block and then cast the exception. So we can keep directly, instead of getting the instance of the coroutine and call the cancelable or method on that when it is timed out. So we can keep that coroutine with timeout function, and that function, it passed the argument as a timeout time, and when the time reached, it cancelled the coroutine. So composing suspend functions. In coroutine, we call the functions. Coroutine consists of a suspend function, and suspend function calls sequentially. If we want, so by default, all children coroutine executes sequentially. If we want that coroutines to be executed parallelly, we call that coroutine with the builder, async builder. So like this is that example I have taken from the Kotlin document and developer document, that is do something useful and do something useful too, and there is a methods we call in async so that it calls on parallelly, and when you call it returns a job. And the difference between a launch builder and async builder is the launch builder, it doesn't return any value from the coroutine, but async, when you call on async builder, we can return a value from the coroutine, and that value we can get by calling that await method on that job. So when we call await method, it waits till that coroutine to be completed, then it gets the value. So that we can same job, we can call a cancel method on that job. So if you want that routine with started with async builder, so that is deferred is a cancel job, and we can call await till coroutine execution completes and gets a value written by the coroutine. And coroutine can be started lazily, and here it is when the statement is executed, it start executing that coroutine. But we can start when in the programming logic, and when in our logic we can start whenever we want that value written by the coroutine. So we'll start at that point of time and we call await to get the value. So coroutine, you can start lazily whenever is needed, and that we have a syntax called that lazily start syntax. We need to follow that. And coroutine always propagate through coroutine hierarchy like functions, and when throw an exception, if it is doesn't catch by the function, it catch by that calling function. And in the same way, coroutine ended with exception, it propagate through coroutine hierarchy. So as we initially discussed, and that is the context and dispatcher. So coroutine dispatcher confined a coroutine to a thread. So we have options to not to confine a thread to the coroutine and to run a coroutine in a main thread itself. That is, we can give a context here like this. We can, while defining this child scope, we can define that it is unconfined, default, and main and IO. So we can define a dispatcher which is unconfined, and it is unconfined, and so that means that it runs in the main thread. And but after resume, and the suspend function determines the thread, and so that is what. And when suspends and that thread is when when suspense and resume, and when resume dispatcher confined to another thread, so it determines the which thread to be confined to that coroutine. When we call the coroutine dispatcher unconfined, and initially it's called it's run on main thread, but after resume it runs on that another thread. So all coroutine builder, and whether it is async or launch or extension function of a coroutine scope. Thus what these builders are the extension function of that main coroutine scopes class, and we get, so on that coroutine scope instance we can call a cancel, so that all routines launch that in instance will be cancelled. So in Android we call a activity, an activity, as long as activity exists, and all coroutines lifetime of coroutine will be the lifetime of activity. So when, so we coroutines factory provides the main scope in the activity, so that on that main scope we can launch that coroutines. So when activity is destroyed, and we can cancel method calls on that main scope, so that all coroutines in that activity will be cancelled. So in the same way, view model, and view model, the factory coroutine factory provides the view model scope, and on that scope we can cancel coroutines when view model is cleared. So that is about coroutines.